Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and the title of this lecture is, for those of you who would welcome a review of the prerequisite material about logarithms, I have two references. One is you certainly can read and study chapter 1.6 in your book where they talk about logarithms. A more gentle and probably more thorough review can be found in the do-it-yourself reviews developed and provided by the Learning Commons under Cheryl Martin's leadership. They have an assortment of YouTube videos where this stuff is covered. They have summaries of the properties. They have practice problems, and the practice problems are, in fact, worked with complete solutions. But we are studying the calculus of such functions. So we're going to begin by considering the function y is equal to the natural logarithm of x. And the graph of this is the blue curve that we see here. Now, whenever we say y is equal to the natural logarithm of x, that means that we are really talking about y is equal to the logarithm base e of x. This is called the logarithmic form, and the exponential form that is associated with this logarithmic form says that e to the y equals x. So this is equivalent to e to the y equals x. This is the expression now that we can use implicit differentiation on, because y is indeed a function of x, and we can use the chain rule. So what we're going to do is use implicit differentiation on both sides of this. This side is quite simple. The derivative with respect to x of x is going to be 1. The derivative of this side by the chain rule is going to be e to the y times dy dx. But now we can take this expression and divide both sides by e to the y, because e to the y is never 0. So we've solved for dy dx, and dy dx is equal to 1 over e to the y, and 1 over e to the y is equal to 1 over x. Now, if we look at this curve, we can say, oh yes, that does make sense, because the red curve is 1 over x, and the blue curve was the natural logarithm. And if we think about the derivative being the slope of the tangent line, here the derivative is a very large positive number, and here the value is a very large positive number. As this gets bigger, x gets bigger, the slope gets smaller and smaller, still positive, but it approaches 0 just like this function. So you see, it does make sense that the derivative of the blue function is the red function. We also have studied the chain rule even further though, and we know then that if we have y is equal to the natural logarithm of u, where u is a function of x, then dy dx is going to be equal to dy du times du dx. But dy du is going to be 1 over u. So if y is equal to the natural logarithm of u, then dy dx is going to be 1 over u times du dx. Finally, we have a change of base formula, and so we know that if y is equal to the natural logarithm base a of u, then dy dx is going to be 1 over the natural logarithm of a times 1 over u times du dx. These are the formulas that you want to commit to memory. Let's do some examples. Here u is equal to 2x, so the derivative on the outside is going to be 1 over 2x times the derivative of 2x with respect to x is that. So I get 2 over 2x is 1 over x. Here the function on the outside is the natural logarithm. The function on the inside is x squared plus 1. So the answer to this, the derivative is going to be 1 over x squared plus 1 on the outside times the derivative of what's inside, which is 2x. So this is our answer to that problem. Part C, we're taking the derivative with respect to x of a product. This is x times the ln of x. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. But that's going to then be x times The derivative of this is 1 over x. And this is ln x times the derivative of x is 1. And so this is the answer to that using the product rule. Example D is a little bit different. On the outside we have the function is being cubed. The inside function is a logarithm. So the derivative of this with respect to x is, you start on the outside, work your way inward. It's going to be 3 ln of x whole squared times the derivative of the inside, which is ln x, which is 1 over x. And so this is the answer that we get, 3 ln of x whole squared times 1 over x. Here's a problem for you to do. You know what to do. Let's see how you did. And if you took the derivative, it's going to be 1 over the stuff that's inside times the derivative of the stuff that's inside. And that's going to be 2x plus 2. Here is another example. These are 3 problems you should do. I notice that here we have some bases that are not base E, but that's okay. You know what to do. Let's see how you do. And I will see you in